Hello friends, we are discussing the Hackerrank linked list module, and today we are going to solve the fifth question of the Hackerrank module, that is the delete rule. So let's try to read this statement. This is saying that we have to delete the element at position given. So for example, if this linked list is given 0, 1, 2, 3 and the position is 2, it means that we have to delete the third node. Here it is assumed that the counting is starting from 0. It means the 0 is the first node, 1 will be the second node, and 2 will be the third node. So for deletion of any of the node, we need to have the previous pointer concept. So let's say this is a very useful concept. Let's say this is the linked list given to us. And in this linked list, if I have been asked to delete the node at position number 2, then I have to, the position is 2. In that case, let's take a counter and let's initialize this counter to 1, and let's take p to point to the first node, and let's take a previous pointer concept. Previous is q. Previous means the previous of p is q. Initially, when p is pointing to the first node, q will be null. So I will be moving p and q simultaneously. So since the c is less than the position, I will move this p to point to the second node and q to point to the first node. So q is the previous of p node, as you can see. Now I have incremented this c. It is 2, which is less than or equal to position. Then I will increment it once again. So p now takes the address of this node and q is taking the address of this node, means the second node. So now I increment this counter once again. And now this c is 3 and the position is 2. This is not less than or equal to 2. So I'll stop my process here, and then I will try to delete the element after this q. So deletion of the node after q is very simple, wherein q will now take the address of the node next to p. You can just simply write that q.next is equals to p.next, and your deletion is done. In case you want to deallocate the memory, in that case you can call the free function, wherein you can pass the address of p node. Now here it may so happen that the traversal process which is going with the counter never increments the p. It means if the position given to us is 1, in that case, if the position given to us is 1, in that case I have to delete the second node. But if the position given to us is 0, in that case I will have to delete the first node. So the loop will never progress this p. P will be here at the first node itself, and q will be null. So q equals to null will be an indication that I have to delete the first node. So you know it well that for the deletion of the first node, you simply have to shift the head pointer to point to the next node. So let's try to write this code. Now this is the function given, and in this function we have been given the address of the first node, which is list, and we have been given the position at which I have to make the deletion. So let's take some temporary pointers. Let's say p and q are the temporary pointers. I'm saying that q is taking the null value, and then I'm saying that p is taking the address of the first node. Now I will take a counter also. Let's say there is 1, and by the time this counter is less than or equal to the position given, I will move this q at p, where currently p is, and I will move this p to the next node. So this way q will always remain behind this p. The moment c is equals to position, I will have to delete the element. So if this q remains null, that is an indication that I have to delete the first node. For the deletion of the first node, you simply need to shift this list to list.next. It means that this list is pointing now to the second node. If it is not so, in that case I have to delete the node after the p node, after the q node, sorry. So I will say that the next field of q will now take the address which was taken earlier by the p.nets. So this way the setting is done and the deletion is also done. If you want to free the allocated memory, you can use the free function. I'm not using it here. So you just have to return the address in the first node, which is list. Let's try to run this code. There is a very simple mistake that I can move ahead only by the time P is not null and C should also increment. I have not incremented this C. You can see that the sample test cases have got passed and the other test cases have also got passed. So thank you so much for watching this video.